Alright, adding and subtracting radicals here. I've got 3 square roots of 5 plus 7 square roots of 5. Some things we gotta know. You'll be quiet with some things we gotta know. Holy crap. What is today? Wednesday? When I miss days of school, I can never figure out what day it is. It's Wednesday? Okay. Alright, so Monday we did some multiplying with radicals, and the deal when we multiplied is the root had to be the same. Like square root, we could do that. Fourth root, we could do that. The stuff underneath it didn't matter. When we add and subtract, the stuff underneath also matters. So 2 things to check when you're adding and subtracting. The root's got to be the same, like square root, yeah. And the stuff underneath has got to be the same. So 5 and 5. When I'm adding and subtracting, I kind of pretend that's like a variable. So I would say, well, this is exactly the same as that. It's like terms. If what's underneath the roof is not exactly the same, it's not like terms. You can't add it. You can simplify it and make it be the same. But it's got to end up being the same. So here I got 3 of these things. This is the way Coach Rod's dumb brain works. Here I got 3 of these things plus 7 of those things. So that leaves me with 10 of those things. And that's it.
So we don't have to break it down.
Because 5 won't break down. We're going to get some that do here in a minute. Alright, so this one I've got 2 square roots of 11 minus the square root of 11 plus 3 square roots of 44. Okay? So what we've got here, if we just go left to right, that gets us a pretty good start. Because I could say the square roots of 11 and square root of 11 is the same, so 2 of them minus 1 of them, right? So 2 square roots of 11 minus 1 square root of 11. This piece would simplify to 1 square root of 11. Okay, but now this piece over here, it's not a square root of 11, so am I done? No, because it can break down, right? 44, the square root of 44 is the same as 4 times 11. There's that 11 that we need. What's the square root of 4? 2, so 2 gets to come out and play wiffle ball. 11 has to stay in the house. Okay, but here's a key. This was that. Good. Whoever just said that's already got it. I got a 3 out in front of mine. Good. I had a 3 out in front. Now there's 2 out in front, so you're multiplying. When that 2 comes out to join the wiffle ball game, you multiply. So 3 times 2 makes that 6 square roots of 11. Which that would end up being 7 square roots of 11.
I'm sure they understood it.
Yeah, they do.
Bless you.
Wait, oh my gosh.
Shelby need a floating.
It was like,
Yeah, she did. She said, what?
do I need a floaty?
That's somebody.
Yeah, my dad was talking.
Yeah, we're gonna look actually. She was like, hey, look at how much they left. He's still
No,
not.
I mean, I know how.
I kind of said it shows that she's kind of greedy. They were having a businessman and they're kind of greedy. And so she was greedy by like refusing to give them the bread and stuff. She's gonna do better. But interpret it whatever they use.
What if you like
Drown in the lake or something? Yeah. Well, you can go.
Alright, we got, y'all listen, shh. We got 5 square root of 12y plus 6 square root of 75y. As it is, we don't have anything we can do to it, right? But I know that 12 and 75 are both going to break down. So if I look here on the 12, what's the biggest perfect square that'll go evenly into 12? 4. So this is the same as 5 times the square root of 4 times 3 times y, right? Let's just stick with this side and simplify it all the way first. Okay, what's the square root of 4? What was the point in that? Square root of 4 is 2, so a 2 gets to come out and play. There's already a 5, so 2 times 5 makes that 10. 3 in the y don't break down. They got to stay in and clean their room. All right, now what about with the 75? What's the biggest perfect square they're going to 75? 25 times 3. Okay. Good. I had to think for a minute. You were so far ahead of me. Square root of 25 is 5. So when Blake brought that out to play, 5 times 6 is 30. And then you still have your square roots of 3y. So can you simplify that now? Yep. 10 of them plus 30 of them. 40 of them. We've got negative 2, fourth root of 32, minus 7, fourth root of 162. So we just jumped up in our roots. We're not just square roots anymore. And that's really the only way that you can get real complicated in this is when you get with some roots that you're not familiar with working with. But the good thing to always remember, if you can figure out one side of it, you can figure out the other side. Because in order to be able to subtract this, you got to end up with the same thing under both of them, right? So 32, that one's a pretty simple one. Anybody know what the biggest perfect 4 that'll go into 32 is? We need some perfect 4s. 1 to the 4th is 1. 2 to the 4th is, hey, doesn't that work pretty well? So this is going to be negative 2 times the 4th root of 16 times 2. What's the 4th root of 16? I just showed you over here. It's 2, so I multiply that by the negative 2. That gets me negative 4 fourth roots of 2. Now here's what I was talking about. If you can figure out on one of them, you can figure out the other. For me to be able to subtract this, it has to end up with a 2 underneath. So that's all I'm going to check and see is how many times does 2 go into 162? Would that be 81? That was interesting. What's the 4th root of 81? Yes, it is. So I'll bring that 3 out. Multiply by 7. That makes minus 21. 4th root of 2. So now be careful on your signs. Negative 4 minus 21. Yes, sirree.
Let me know when you get back because I forgot that there was something like that. Yeah, it's okay because those things across the phone.
Would you write me the last step? From Tibia. Okay.
Alright, you got the cube root of p to the 4th, q to the 7th, minus the cube root of 64p cubed. Okay, so don't have anything that we can subtract as it is. If I look on the one on the right with the 64, I'm zoning in on that PQ, it's just got a PQ. So somehow this left side has got to end up with just a PQ. All right, so let's break, since this is cube root, let's break these down into perfect cubes. That would be a p cubed, but it's got to be 4, so there had to be another p. On the q, if I did a q cubed, that's hard for me to say. Another q cubed, there's 3, 6. I need 7, so I got to have another q there. All right, now remember, a cube root and a cube cancel out. So the cube root and the cube cancel out. That p gets to come out. This p is a first. I can't bring it out, so it's going to have to stay in. Cube root and a q cancel out, so that q gets to come out. Here's another one, so another one gets to come out, so that makes that a squared. This q has to stay. So I've got pq squared, the cube root of the stuff that had to stay, p and q. Alright, on the right side, I got a pq underneath there, but there's a 64. Is 64 a perfect cube? Good, so bring the 4 out, so I got minus 4 cube root of p cubed. Now I can't combine, I don't really know what pq squared minus 4 is. I'm just going to write pq squared minus 4. And then I got the cube root of pq. Alright, a couple more things to look at. Everybody got what we need here? Though, you're good. Those kind, they're not hard, but they're just take a little longer than the first ones because they don't simplify down as far. This one here, we've got 6, let me get the page to turn, there we go. 6 cube roots of 16 z to the 7th plus 4 square root of 200 z to the 5th. Alright, so dilemma though, we're going to start simplifying some stuff down here, but dilemma is I got a cube root and a square root. So maybe I might be able to add them in the end, maybe I won't, I don't know. Remember Monday we figured out how to use our power over root to get the roots the same. Like a cube root and a square root, I could make them both be 6 roots. Remember we talked about that a little bit Monday? But we're not, we first just need to break this junk down that we have here because it can be broken down. 16, perfect cube, no, right? 2 cubes 8, 3 cubes 27, but I can put an 8 into it. I can't bring it out all the way, but I can put an 8 into it. So it's going to be the cube root of 8 times 2, z to the 7th will be z cubed, and z. Alright, we ready to break the stuff. Cube root 8's 2. There's already a 6 out there, so 6 times 2 makes out a 12.
12z squared.
Good. Cube root of z cubed is z, and I have 2 of those, so z squared. And then you got your 2 and your z in there. Alright, over here with the 4, now this is a square root. So I got 4 times 200 is not a perfect square. What's the biggest perfect square that'll go into it? 100, good, times 2. And then z to the 5th will be z squared, and z. Alright, square root of 100 is 10. There's already a 4 out there, so 10 times 4 is 40. 2's got to stay. Square root of z squared is z, and I've got 2 of those. So then that z will have to stay. So I've got a 2z in there. that's as far as our book answer goes. I was thinking we might have to make them both be sixth roots and go farther, but that's as far as we got to go on that. Thank goodness. Yeah. All right, last thing that we got to look at is when we got fractions involved with this stuff. Let's do a fraction one real quick. I got 2 times the square root of 32 over 36 plus 2 times the square root of 27 over the square root of 108. Alright, so remember what we're looking at. The right side, they wrote it that way. So here on the left, this is the same as 2 times the square root of 32 over the square root of 36. Let's just go ahead and break all this stuff down here. So this is the same as 2. Biggest perfect square that'll go into 32 is 16. Square root of 36. Y'all can go ahead and rewrite that. Okay, what's the square root of 16? 4, so you got 2, 4 square roots of 2 over 6. Now if you're multiplying 2 times all of that, I mean, you don't have to write it this way, but I see it better if I look at it like that. So that means I'm multiplying 2 to all this. So then I would look here and say 2 over 6 reduces to 1 over 3. So I would have 4 square roots of 2 over 3. Alright, so now to the right side. 27, biggest perfect square going to 27 is 9. So we've got, go ahead and put that parentheses this time. About 108. What's the biggest perfect square that'll go into 108? I think it's 36. Is that right? Somebody check me and see if 108 divided by 36 is 3. I think it is.
You are correct.
Good. Alright, so on the top, the square root of 9 is 3. And on the bottom, the square root of 36 is 6. And I like this because what do we have? What do we have here? So doesn't that?
Yeah.
And then that'd be 1/2 right here with the 36, right? And what's 1/2 times 2?
1.
There you go.
Oh.
So we've got 4 square root of 2 plus, over 3 plus 1. Now, I like that, and when I was working through this morning, I circled that, but then I went to check it in the book, and here's how the book had it written. Let me show you, see if we can figure out. Plus 3 over 3. That's how the book had it written. How's that the same thing?
They ration out the denominator. Another one.
It'd be right here where I put plus 1, they put plus 3 over 3. So they got a common denominator, right? 3 over 3, so 3 over 3 is the same as 1, so that's what they're doing with that common denominator, which would be kind of what Blake was saying, yes.
Oh, but we can leave it how we do it.
Yeah. Okay. Alright, tomorrow's stuff, we're gonna be multiplying and dividing with them. So we simplified them on Monday, we added and subtracted them today. Tomorrow, we're gonna be multiplying and dividing. Everybody alright?